Right. So then we discuss Boyle's law. You can hear me, right? Cha. Okay. Cha. Chanuri. Right. Okay. We discussed the Boyle's law. Right. So Boyle's law means the how the gas pressure is changing with the volume of the object. We discussed when the pressure increases, the volume decreases. So therefore, we can write this equation P1 V1 equals P2 V2. That one we discussed, right? And we did these two questions as well, I guess. Okay. Right. Right. So then next part is how the gas pressure is variating with the temperature, right? Now before that, what we have to discuss is what is the measuring unit. Normally, what we use to measure the temperature with the measuring unit. Normally, we use Celsius, right? Degree Celsius, but the SI unit of measuring temperature is Kelvin, right? Now the Kelvin temperature scale, another term we use for this one. Sometimes we call it as absolute temperature. Absolute, right? So absolute temperature, or sometimes we can call it as the thermodynamic temperature. Right? So different names I use, right? So this thermodynamic name we don't have know it now, right? So only thing we have know is the absolute temperature, right? So sometimes if in a question, right, so if they ask what is the absolute temperature of something, that means they're asking about the Kelvin temperature. Okay, right. Now if you have a Celsius temperature, right, how to convert it into Kelvin? That's the first thing you have to know, right? So there's a very simple relationship, right? So if you have a Celsius temperature, if you want to convert this into Kelvin, right, what you have to do is simply you have to add 273. So then you will get the answer in Kelvin. Now actually it is 273.15 in real situation, but we don't use the 1.5 value. We just add just 273. So that means if you have a Celsius temperature as let's say 20 Celsius, right? So then 20 Celsius we can convert this into Kelvin by adding 273. That means 293 Kelvin. Clear? Right. So since you have this note, right? Yeah. The here mentioned here how to convert, right? So Kelvin temperature equals Celsius plus 273. Or just write with the symbols K equals C plus 273. Okay. Okay. Right. Okay. Now we can see how the temperature is affected by the how the temperature is affecting the gas pressure. Right. So it's like this. Now go back to the board. Right. Now let's say we have a gas inside this container. Right. So the gas particles are always moving randomly, right? So as they move they will collide with the wall, so that is what causing the gas pressure. I think we discussed that, right? How the gas pressure is exerted, right? So in the lesson we discussed there, right? So considering a gas, right, so gas particles always move randomly. Due to this motion they collide with the container walls. These collisions exerts a force on the wall, and the force causes the pressure, right? So that's how the gas pressure is exerting. And remember this one, they always ask about this, right? So how the gas pressure is occurring. So then just keep this one in mind. Okay, right? Then so when they move, right, so they are exerting pressure, right? So if you increase the temperature means, right, so remember when you are increasing the temperature means you are supplying thermal energy, right? So increasing the temperature means you are supplying the thermal energy, right? So when you supply thermal energy, what happens is, right, so then that heat, thermal energy means the heat will be absorbed by these particles, Okay, so these particles absorb the thermal energy. So then what will happen when they have more thermal energy inside the particle? So that energy will be converted into the kinetic energy. Okay, so that means their kinetic energy increases when you supply more thermal energy. As a result, what will happen? The speed will increase, right? We know the kinetic energy we discussed in the previous lesson, half mv square. Okay, so therefore, yeah, so then when the kinetic energy increases, the speed of the particles will be increasing. When this speed increases means they will move faster within this container, right? So therefore, when they move faster, what will happen? They will collide more frequently, right? So you can say more collisions occur within a certain time. Understood? Right. Okay. If there is more collisions, remember, so then if there is more collisions means they will exert more force. As a result, there will be more pressure, right? So it means, yeah, yeah. Yeah, temperature is, yeah. If they ask what is happening, first mention when the temperature is high, the particles will have higher kinetic energy. So therefore, they move more faster. So as a result, they will have more collisions. Then more force will be there. So when the more force is there, means we know the pressure equals force divided by area. So more force means more pressure, right? So that's what I think it's mentioned in the note as well, right? We'll check. Yeah. So pressure of the gas increases. Okay, I'll just see this one. Yeah, here. So this paragraph here says pressure of the gas increases as the temperature increases. Pressure gets smaller as the gas is cooled. The pressure. So that one is mentioned, right? So this part first we'll go through this one, right? So then we go back to that part. When the temperature of a gas is increased while keeping the volume constant, pressure of a gas increases as the temperature increases. This is because the particles will have more kinetic energy and they will move faster. Then there will be more collisions, causing more. Here actually it should be written as more force, which leads to more pressure. Okay, just adjust this sentence there in your note, right? So the last part, then there will be more collisions, which the walls causing more force, which leads to more pressure. Mention that in the note, right? So if you draw the graph between the temperature, right? So then if you draw the temperature in Kelvin with the gas pressure, how are they changing? So then pressure and temperature in Kelvin, the graph will be a straight line starting from zero like this. Okay, but if you draw the graph variation between the Celsius temperature, right? So graph is starting from there, right? We know this is starting from behind, right? So we know 0 Celsius means how much in Kelvin then? No, not just 273, right? We know Celsius plus 273 is equal to Kelvin, right? So then Kelvin is 0 means C plus 273 is 0. Then Celsius equal to minus 273 Celsius. Okay. So now if the graph is starting like this in Kelvin temperature, right? You can see when the pressure is 0, uh, Kelvin temperature is also 0. So then this temperature, Kelvin 0 temperature is equal to minus 273 Celsius, right? So therefore, when the temperature is in Celsius, if it is minus 273, then the gas pressure will be 0. So then we can draw the graph like this. Clear? Okay. Right. Okay. Right. So then that is the graph that should be going there. Right. So then this is the gas pressure variation with the temperature, and this value is minus 273, right? When you are drawing it, draw it as a straight line, right? Keep the ruler, right? So draw those two graphs there. So if we go back to the board, right? Now, now understand this one carefully, right? So now if you have a gas, so then if you supply thermal energy, what will happen? The pressure will increase. Particles starts to move faster, right? So that's what just discussed. When the particles are moving faster and the pressure will increase. But if you remove the thermal energy, what should happen then? Yeah, yeah, then the particles will lose kinetic energy, so then they will move slowly, right? So then they will have a lower pressure, right? So then when you're removing the thermal energy, right, so the particles are getting slow and slow. Okay, so at some point the particles should be stop moving, right? If we continue to remove the energy, isn't it? Yeah? So if you continue to remove the energy, at some point the particles should all the particles should stop moving. So that means at this point onwards, there will be no energy remaining at all. Okay. So when this happens, that temperature, right? That temperature is equal to 0 Kelvin. Understood? Right? So when the energy is continued to remove, the particles will be completely stopped, right? So this temperature is equal to Kelvin 0, right? So normally that temperature is labeled as Kelvin 0. That's how the Kelvin scale is made, right? So when this temperature is 0, right, so we call this one as absolute 0, right? So we call this temp. Yeah. Okay. So then this temperature is also known as absolute 0. Now the important thing is, now this is the minimum temperature that has been ever observed in the entire universe, right? So this value is equal to minus 273 Celsius, right? So this is the minimum temperature that we can have, because if you try to go below this temperature means, right, so you have to remove more energy. But when this happens, the particles have already stopped moving, so that means there is no more energy remaining. Okay, so therefore this temperature, for now, at least for now, maybe in the future, who knows, it might be changed, right? If someone is discovered something else, but currently, so this 0 Kelvin, or the minus 273 Celsius, or the absolute 0 is identified as the minimum temperature possible in in anywhere, in any object. Okay. Right. So that's what mentioned here, right? After this Kelvin scale, right? So pressure of the gas increases as the temperature increases. The pressure gets small as the gas is cooled. The pressure of the gas cannot become less than 0. This suggests that there is a temperature below which is not possible to cool the gas further. This means this temperature is called as absolute 0. Then the absolute 0 is the lowest possible temperature. The Kelvin temperature scale starts from the absolute 0, and the temperature, this temperature is labeled as Kelvin 0. Okay, right? So then this relationship you have to know, right? So then the pressure and the temperature, right? So when the temperature is increased, the pressure is increased, right? Now this value, right? So we can do it in a calculation, right? So then relationship between this temperature and the pressure, gas pressure, we can do it as a calculation, right? So remember, the pressure is directly proportional to the Kelvin temperature, right? So remember, this is always Kelvin value, right? When you're doing the calculations, keep that in mind, right? So then when two things are directly proportional, that means they have a constant relationship, that means constant ratio, right? Let's say there is a one situation where the pressure is P1 and the temperature is T1. So then their ratio is P1 by T1 is a certain constant, right? If we increase this one's temperature into T2, then the pressure also will be increased into P2. So then P2 by T2 is also a constant, right? So then combining these two, we can write the equation P1 over T1 equals P2 over T2, right? So by cross multiplication, after that we can arrange this into P1 over P2 equals T1 over T2, right? So this is the relationship that we use in calculations which are related to the temperatures and pressure. Understood? Right. So we are not writing everything, we'll just write the relationship. So pressure is directly proportional to the absolute temperature, right? So that means pressure is directly Yeah, yeah. I shared it. So then we can write the equation P1 over P2 equals T1 over T2. Write this equation there. Try this question. Right. Right. First one, just in both situations you have to use the equation P1 over T1 equals P2 over T2, right? No, I gave the other way, no, sorry. P1 over P2 equals T1 over T2, right? Right. So then the pressure, new pressure is what we have to find now. Initially, gas is at 1 into 10 to the power 5 pressure at 27 Celsius. So we are increasing the temperature up to 127 Celsius, right? So then this is the initial condition P1. This is T1, but in Celsius. Keep in mind you have to convert. So then P1 is 1 into 10 to the power 5. You have to find the new pressure. T1 is 27 Celsius. To convert that into Kelvin, you have to add 273. So then this is the new temperature, that is 127 plus 273. Okay. What do you get for the P2? Okay, that's a very common mistake. Everyone do that, right? So therefore, very careful when you're using this equation. That's why we are using capital T. Normally, the capital T symbol is used for Kelvin temperatures, right? So if it is Celsius temperatures, normally we are using theta. Right? Tell me the answer. Okay. So then 1.33, 1.3 into 10 to the power 5, right? Okay. So second part, now what is happening? Again, the same initial pressure, right? So 1 into 10 to the power 5 is the room at pressure, the initial pressure. The temperature was 27 Celsius, right? So what do you have to do? We have to reduce the pressure up to 6 into 10 to the power 4. Okay. So we have to find the new temperature, right? So again, this is P1, then this is T1 in Celsius once again, right? So then this is the P2, and we have to find the temperature of T2, right? Again, use the same equation P1 over P2 equals T1 over T2. So then P1 is 1 into 10 to the power 5 divided by P2 is 6 into 10 to the power 4. T1 is 27 plus 273 divided by the T2. If you use this way, right, the answer is coming in Kelvin, right? So we are just using the T2 directly. So answer is coming in Kelvin. What is the answer we are getting? Yeah. Chanu, 180 Kelvin, right? Some, if you want to convert this into Celsius, right, we can do it. Celsius plus 273 is Kelvin. So then Celsius is 180 minus 273 is how much? Minus 93? Minus. Minus 93 Celsius, right? Now that one check, right? So, when it comes to papers, sometimes they asking the units to be given in Celsius or Kelvin. That depends on the temperature after the space they leave the units. Okay, so check which one is given. So based on that, you can give the final answer, right? Clear? Okay, right. So then I think I shared this PDF in the group, right? As I remember. Okay, right. So there must be a question related to this part. I'm not so sure though. Right, so okay. Right, so then not no question from this section, but try this first question though. This is related to the Boyle's law and everything. Take few minutes and First one, go through this. Right. The tire excess pressure on the ground 270 pascals. The area of the tire is 0.16. State the equation linking pressure, force, and area. That is, pressure equals force by area. Calculate the force exerted. Yeah, force exerted on the road by the tire. So then we know force is equal to pressure into tire, right? So then pressure is 270 kilopascals is there. Better convert it into pascals by multiplying with 1000 times 0.016. Did you convert it into pascals by multiply by 1000? Okay. Okay. So 20 newtons, right? Use the ideas about molecules to explain why the air inside the tire exerts pressure. What is happening? So write like this now: the gas particles, so air particles, right, randomly moving, right? So when they randomly move, what happens? They collide with the walls, right? So each collision exerting a force, right? So then force causing the pressure, right? So write like this, right? I mean, not this way using arrows, right? So just mention gas particles move randomly, they collide with the walls, then they exert a force, right? So that force causes pressure. Okay, right. Next one, air is pumped into the tire to inflate it. The increase in temperature and the pressure on the air is pressure of the air in the tire. Use the ideas about molecules to explain why the air pressure in the tire increases, right? So that one, the last part we just discussed, right? Uh, hmm, hmm. Okay, right, clear, right? So then now you can try actually the remaining questions as well, right? So since this lesson is actually finished, right? So then you can try all the question and sorry, really, okay. So the remaining also you can do, and some questions are from the unit four as well. That means lesson number four. Okay, right. So then we may have done something by when we are doing that lesson, right? So try. Okay, so if anything important, I will discuss the next time, and also means probably we will start in the next lesson as well. Okay, I will share the lesson notes as well for the next lesson, right, and we'll continue. Then we'll continue next week on the same